PhD from VTU. His research interest basically includes new materials, automation and control. He has over 25 years of experience, out of which 10 years is in the industries and remaining in academia. He was given an opportunity by Visvesvaraya Technological University VTU to undergo training in automation technology at Germany, and later on worked as special officer for VTU during 2006 and 2011 mainly to develop a center of excellence in automation technology in collaboration with Bosch Rexroth. This assignment has given him a lot of strength to solve technical problems in the field of automation. As a result of this experience from 2011, he is basically working as professor in NIE, National Institute of Engineering, and program coordinator for industrial automation and robotics. He has also part of the team which has developed Center for Robotics and Controls and Center for Automation Technology to support research scholars in the area of sensor materials, material coating, automation, robotics, and IoT. During the period of 2006 to till date, he has conducted several trainings with more than 3,500 students from across VTU institutes, VTU affiliated institutes, and he has trained more than 600 faculty from different states. And for this contribution, he has been honored by Visvesvaraya Technological University during the year 2019. Sir has a lot of publications, wide publications, more than 30 publications. He has filed 2 patents, and he has served as a resource person in several training programs, which has trained faculty members from different states such as Tamil Nadu, Maharashtra, and Gujarat. So with that, I would like to extend a warm welcome to you, sir. Welcome to this program. And I would like to
good morning. Thank you.
Yeah. So I would like to hand over the platform to you, so you can take over, sir.
Can everyone see the slides now?
We can see, sir.
Okay. Thank you very much. So, good morning to everyone. I'll be talking on how the existing labs of engineering institutions can be converted into an IoT laboratories. So this is a unique presentation maybe because most of the time the colleges used to get codes separately for IoT lab development processes. But last 2 to 3 years back, after getting all the expertise in the field of automation, robotics and controls, I was thinking we have already developed a worth material of around 2 to 3 crores or 4 crores. But this total investment can be moved towards IoT platform. So this was the question in my mind. And slowly I started working towards that from last 2 years, and now we have already developed our own methodology to convert existing labs of an engineering institutions into an IoT laboratories. So as I said, it will be a different exposure. Every faculty or every participant can think towards converting the existing to a IoT base. Okay. So my presentation will cover more of the contents will be introduction to automation, introduction to IoT, Center for Automation Technology. This is our center, what we have developed from the last 4 years through different funding supports. And after developing this, thought focus of converting this center into an IoT based center is that is the main focus of the day. And areas considered for conversion. So why I had given this content is, naturally we cannot consider all the materials that you have in the laboratories which can be converted into an IoT platforms. However, we have to choose based on the existing facilities or the availabilities of the systems within it. Can it be taken into an IoT or not? This question has to be asked by everyone before they consider the systems or the equipments to convert into an IoT. And once you make a list of such things, architecture, how you will do that? So what is the architecture of it? That will be taken, and a few case studies of what we have converted. So basically, I'll be concentrating more on a hydraulics laboratory. So wherein we have converted the existing hydraulic kits, and we are trying to monitor the parameters using these laboratories. And continuously we are taking the data, and data analysis is being carried for generating the good papers on AI, ML, these kind of areas, key areas basically. And also one more important thing was, when we say IoT, this is more related with sensors. So without a sensor, no IoT can be made. So I'll be quoting few examples of how the sensors lab has been converted into an IoT. Existing sensors labs have been converted into an IoT labs. And also I'll be taking a case study on PLC or any other controllers what we have. So let us cover one by one. So let me talk what is industrial automation. So automation is the use of control system. Normally, in the olden days, we used to work with the conventional methods by putting a man with the material and basic conveyors and other things. Slowly, when the automation progressed, so the lot of control equipments has pitched in into the equipment of the machinery, and which has made the machinery smarter and avoid or reduce the interventions of the man and the material movement in the process. So this is not only applicable to industry, as I said, it can be applied to a robotics area, computers area, or any other area. Ultimately, the target is reduce or replace the human being intervention and making our processes much convenient and easier. So when we say the automation, so an industry or a factory or a shop floor, whatever it is, or even a grocery shop, whatever we consider to automate, which may have a lot of machineries and instruments or some kind of PCs. So a lot of things involved depending upon the area where we are trying to automate. And we will be adopting a few controllers and a few sensors, hardwares and softwares to make them more smarter and to make ourselves convenient to reduce the burden on the process requirements. So now let me take what is an IoT. So when we look at this slide, it is nothing but the interaction of multiple technologies with the ability to send data over the internet. So that means we have something, a lock. So somebody is opening the lock, you are out of station for a few days, and if somebody try to open the lock and you get a signal, my home lock is open now. So means we are trying to between the devices and between the people like this. So it can be from any machine to any machine, machine to people, people to some other systems to automatically handle the situation. So this is the overall a kind of a networking, internet connection oriented networking of group of devices, people along with to make more smarter and make it convenient for the user. So only 2 slides I have taken, so just to brief you about what is automation and what is IoT. Now I'll be pitching directly into the area of conversion, what I was saying through my slides in the first line. So let me take this. So here, so when we say this, we have developed 2 centers. One is called as Center for Automation Technology, and the other one is Centers in Robotics and Controls. So these 2 were developed with the funding supports from DST and KCTU, Karnataka Council for Technological Upgradation, And along with this, already we are a TechUp institution, so we get a TechUp support also. Through that also we have taken some funding. That is focusing from three sources of funding. We started building a center for automation technology, which has 4 to 5 layers, layering from the basic level to an advanced level. So let me take the base level called as zero level. So zero level, that is, we call it as a device level, and slowly we have put a machine level. So in the device level, we have a sensors, switches, cables, hydraulics, pneumatics, drives, electrical drives, and other things. And in the machine level, we have a CNC, gantry systems, articulated robots, a lot of other robotic process involved equipments within it. So that is a machine level. And level 2 is a system level, wherein a few of the equipments are being controlled through a PLC or a SCADA. A process is being controlled through a SCADA or a PLC. So these kind of systems. And next is level 3 is what we call it as a plant level. So wherein we also have to bring in simulation software. So something, a robo simulation that you create, and you link the simulation software to a hardware, and you try to execute that. Maybe a automation studio is one very good example. Not only that, we have robotic simulation softwares. Many robotic simulation softwares are present. So these kinds of softwares integrated with a hardware kind of thing, what we call it as digital manufacturing level or plant level. So that we have developed. And how we have done, that's also an interesting part. Any engineering college cannot invest 4 to 5 crores or 3 to 4 crores at a time, assuming that we will try to build a very good center in this domain. So it is very hard in this today's condition. So to manage faculties, manage these resources, other resources within the requirements of the today's condition, bringing such a huge amount may be very difficult. So you have to target different funding agencies. So initially we have targeted upon TechUp 1. From the TechUp 1 we have brought CNCs, and TechUp 2 we have brought some softwares like Automation Studio and other softwares. And in the TechUp there we also applied to DST after that, saying that we have already developed this and we would like to go for such a center which can throw itself into a bigger volume. So it can connect to different segments, regions. From one place, we can connect to many places, many people. Like that we have focused and we have presented to DST. And from there we have got a big amount, 1 crore we have got from DST for this project. And now also we wanted some more fund to develop robotics and control aspects, strengthen ourselves in these two domains. So we have approached Karnataka Council, and from there again we have got on PPP based model, that is public-private partnership model, KCT is offering. So from there we got a 1 crore, that is 50 lakh is invested from the institute, and 50 lakh will be given by the Karnataka Council. So taking that fund, putting together, we could able to generate around 5 crores. So, and we started working in this manner to build our complete automation laboratory or a center into a basic center first. And on top, on the level 4, now recently, that is maybe 4 to 5 months from now. So we have started working, converting these equipments, what we have procured, into an IoT based platform. So where this part only I'll be concentrating now. So now, as I said in the beginning, so we cannot take all the equipments. For example, I'll tell you CNC machine here, which we have procured in the equip one, that is 6 to 7 years back. So when we checked that the controller was old, and with that controller we were not able to move the total machine onto cloud. So we dropped it. Ultimately, if we take such kind of thing, so converting the existing controllers to the recent controllers and then doing all will be a costly affair for us. So we cannot do that. So we have dropped that. So like that, we have to see the equipment and analyze which are all possible. And from that, we have made a list of converting first few laboratories into an IoT. So let me tell which are the laboratories that we have taken is PLC laboratory. What is PLC is, we have a Siemens center, so which consists of 1200 and 1500 and SP trainer kits. It is a very well established center. So all these were able to convert to an IoT platform. So we have considered PLC laboratory. So and next, PC automation lab. This is a back-off systems. This is also a very advanced system used for the automation purpose. For example, if you consider a very big processes like airport automation. So there you have a plenty of lights, fans, and lot of control elements. So which have to be controlled. So there people uses a PC because compared to PLC, their PC is better because more number of IOs each PC will have. So there is an advantage of selecting PC there. So I don't comment here PLC is better or PC is better. So each one has its advantages and disadvantages. The selecting guys or the people has to choose accordingly. So as we wanted to give introduction or giving the knowledge to the students in all the areas of automation verticals. So we have developed a PC automation lab from imported from Germany, that is back of Germany we have created. So and hydraulics laboratory, which was supplied by Bosch Rexroth for us. So and Bosch Rexroth is a company which more stronger in the field of hydraulics, pneumatic, and components related to hydraulics like that. So from that company we have developed a hydraulics lab, and there in the hydraulics lab there are 3 stages: manual hydraulics, electrical connections with, and proportional hydraulics. There are 3 verticals to it. We have all the 3. So especially when you have that, you will be having relays, timers, and all these things mounted on the kits itself. That is facility to mount these devices on the kits, and you can wire it through a 24-volt supply and have an automation done like a relay logical circuits. If one knows the relay panels, that is a machine. When you open a machine panel, old panels basically, you find only the elements like relays and other contactors and switches like that. So similarly, we can have a hardware related like that. In the next phase, a PLC has come in the business. So that already we have selected in the number 1 itself. So we have covered now relay logical automation also into an IoT, and PLC into an IoT, and in the hydraulics lab. So we have again all this. It is PLC as well as relay logical. So that has been taken into consideration. One of the beautiful aspects of this hydraulics is, so we can incorporate a sensors like flow sensors, pressure sensors, and many other sensors within the connecting circuits branches, and monitor that continuously, and through that data you can analyze the processes. So I'll come to that part of application when we jump into the next slide. So the next lab is a sensors lab, which is a very interesting lab. We have all industrial sensors and RFID and barcode sensors and a lot of other sensors within ourselves. This is P&F make that we have established here, a very big sensor lab that we have established. So that also we wanted to convert it into an IoT platform. And in the last, we have a KUKA lab, robotic lab, wherein KUKA is being used to pick and place an object which is coming from a conveyor and inspecting that through a vision camera, Cognix vision camera. And based on the defects, so the object is being placed at different places. So we can generate plenty of projects through the robotic lab also. I'll highlight few such cases in the subsequent slides. So here, as I show you here, so the main intention of going to IoT is existing institute laboratories or some systems. When I say systems, I have taken two different verticals here, laboratory and system. So why I have taken this is, we have an RP machine, rapid prototyping machine. So if we bring that rapid prototyping machine to a cloud, so we can generate even consultancy out of it. So like that, a few important laboratories and few important systems are being converted to an IoT. Okay. Please, can everyone mute the mute? Okay. So now the subsequently IoT controllers is connected to a centralized server, and we have already developed a mobile and cloud application, web application system to it. So visualize, monitor, and control the complete laboratories through either through mobile or through global server or a local server. So any student who has been allowed to do that can able to do that. So this is the beauty of the laboratory. So now my next slide shows IoT controller with the different labs that we have selected. So if you look at this slide, so this is a HIDAC IoT controller that we have used. So to this controller, we have connected a server, and we have a web application and as well as mobile application generated for the experiment purpose. This is in the process. We have generated only few cases now. So as and when the time goes, we can generate around 100 to 200 numbers of application, web and mobile application cases. So this is the interesting thing. A continuous improvement process has been used here. So a lot of projects can be given to students in this area, and they can develop that. You can link that to the system and the server, and you can increase your number of experiments. So the programmable logical controller lab that we have connected to the DAC. So this has a standard Ethernet, TCP, IP and ports in it, and we have a hydraulic training system with the integrated pressure, flow, temperature and aqua sensors. So those are connected to the analog and HIS ports of the data controller. So IPC has standard Ethernet and LAN connectivity, so which can interact with IoT controller through a coupler, okay, twin cat coupler, that is Beckhoff coupler. So we have already that has the ability to connect now. So no need of much of a conversion devices in the middle here. So this is the architecture. As a total, if you look at this slide, so how the instruments are being connected. So this is an hydraulic kit with different kinds of sensors. This is a pneumatic kit with the different kinds of sensors. So this is a PLC kit with different PLC kit connected through a data logger to a cloud and a web application, and census lab which is connected to the it. So this is how. So the different labs can be connected as patches. So you can add on the different labs that you have in your college slowly. So that is by selecting it whether it is feasible or not feasible. So and attach them to the existing systems. So this is the advantage. So now let me take one by one. In the PLC laboratory, we have connected the PLC kit to an IoT logger, and IoT logger will in turn connect with the server and the web application as I saw. So in the PLC lab, we have 6 PLCs. So now this architecture shows how we have connected it. So there are Siemens 1206 PLCs that we have taken and 1500 PLC, so which is a very advanced PLC. So this is how we have connected all these through a data logger, and we have even connected few of the sensors through this lab. So using PC directly and to communicate with Ethernet switch and then to a server. So overall, all the laboratory is now being able to connect to the server and to the cloud with an application platform. So if you look at how the PLC and IoT input output lines are being taken. So this is a very simple slide. So we have a different sensors can be connected, digital or analog sensors, motors, any actuators, anything, either hydraulic actuator, pneumatic. You can connect through these devices to the PLC. So, and the PLC in turn will link with the data logger, and data logger link to cloud server. Okay, so configured to the cloud server, and it will link with the cloud server. So this MQTT is being used here to move the data to the cloud platform. So now the next question arises: what is the data logger? How it will look like? So one of the advantage of this data logger, this is made in India product. Recently for the institutions, HIDAC, ours is a first project. We have taken this as a combined effort to convert this and give a very good indigenous material to the education segment. So this has been like a kit we have made. The purpose of making it as a kit is it can be taken to any place. Now tomorrow an MIT calls me, so I can take one suitcase and go there and demonstrate the IoT concepts to the participants or the people who are assembled and come back. So keeping that kind of marketing in mind, so we have developed a kit, and that kit can be carried anywhere and can be even carried from department to department within the institute, so that if you have say 6 to 7 kits in your college, your many number of labs can be converted to IoT as your timetable will be distributed. So you can move the kits to the other department in the other semesters. So you can homogeneously make a table and make use of this platform for a bigger volume of students across the institution. So now data logger within itself has, this is IMX 7D processor it has, and connections like RS-232, one number, 485, HSI, this is a sensor connecting ports. Basically, HIDAC sensors are being connected through this. And as you know, cloud server and a local server provision to it, and analog and digital. In the analog, again, we have taken 0 to 10 volt and 4 to 20 milliamp. So that means the data can be recorded either in terms of a current or in terms of a voltage. Suppose if you connect a sensor. So sensor here means you have to be very careful here. Suppose I am taking a position sensor. What is this position bulb sensor is? So if you move the bulb sensor rod, that is a connected rod. So as you move, it will move by a distance. So, but I don't get the distance directly. I'll be getting the variation either in terms of current or in terms of voltage. However, I have to calibrate, make my own chart or a software to link that to a distance or centimeter distance. However, the software developed can select all these units like centimeter, amperes, voltage, whatever it is. Means uniformly, generally developed software which can meet all these kinds of requirements. Very, very interesting. One has to be very careful here. So you get a readings in terms of current or voltages, but I can convert that current or voltages into a distance or any other parameters. Okay. So I also have analog and digital. So digital 32 we have. So input outputs we have 32 input output. That means a very big PLC normally will have, suppose I take a 1200 PLC which will have 16 input, 16 output. So even if you take 32 input, 32 output, but normally in the colleges we may use not more than 10 IOs or 15 IOs while teaching to the student. So taking that in the concept, so limited to certain numbers, because kit size will become more bigger and it will not be able to carry. So we have restricted the IOs also to meet the kit size. So as you know, 16 digital inputs, 16 outputs, 8 analog, 4 HSI, and 1 RS, 485, 232, and USB Ethernet. Through the USB port, you can connect to your laptop and you can record any data, store any data according to your requirement. And even you can store it in the cloud also. So this is the one advantage. So what is the internals of the data logger? What is inside the data logger? So it has a digital sensor connectors, analog sensor connectors. There is a base board, which is an IO management board, and a processor is there. So along with that, all connecting connectors like what I said, with an LEDs to indicate the healthy conditions and abnormal conditions, and all those we have taken 2 LEDs at the top corner of the data logger. So inside the processor, if you get in, so the processor has Freescale IMX7 socket with ARM Cortex A7 processor with 100 pin connector in it. So which is a HADAC processor basically with a large capability in it, which is a, say, I can say, a mini tab size board, which is being fitted in the data logger inside, and also which has 2 into 5 112 MB RAM with other facilities like USB and other connections to it. So now I have explained you how we have developed our laboratories with a different investment, and how we have selected our components and the laboratories to convert to an IoT, and what is that we have used, what is the internals of the data logger, all those we have covered. Now let me take laboratories one by one with the case studies, because this will be more interesting now. Let me take a hydraulic laboratory. So when I say hydraulic laboratory, there are many components which can be mounted on a test bench like this. So like hard components, hydraulic components basically, which has a power pack at the below. That means power pack here refers to not the electrical power pack, which is a hydraulic power pack, means hydraulic energy. By pumping the oil into the circuit, we generate to move the actuator here. So that is connected through a hoses called braided hoses, which can withstand a high pressure within it, which are the flexible hoses that we use, and connect each of the components here to here, like this. After building a hydraulic circuit, I'll explain one circuit to you, nothing to worry. So an actuator, the hydraulic component, when I take the hydraulic component, as I said, manual hydraulics, electro hydraulics, and proportional. So here I am not considering, because one step we are jumping into a higher level means we have to select either electrical or proportional. So let me take a proportional electro hydraulic thing. When I say electro hydraulic, I need to use a relay board, switches, timers, and those components here. The kit, hydraulic kit has already a provision to it, and they have already supplied these electrical devices also, which is mounted on top of the kit. So only a plug-in type of wires will come and join between the device and this. So using a relay logical method or through a PLC, even you can connect a PLC to this kit. So now this is overall an hydraulic with a connection and a power pack kind of thing. For an IoT purpose, we have pumped in a few extra devices like pressure sensor, flow sensor, temperature sensor, and position sensors, aqua sensors like this. So many sensors we have added in. I've taken 2, 3 here for example. So, and I've showed you what are the sensors that we have pumped into the same kit. So by using all these components, now I'll be developing a circuit trying to demonstrate you how the IoT is being demonstrated here. So in the next slide, the application of areas of, okay, that is, these are the sensors that we have selected: temperature, pressure, aqua, all these sensors. Now the configuration is same. Our IoT logger will connect to cloud and server with a PC or any other systems if you want. So now to demonstrate you that, I have rigged up a circuit using the same board. So this is my power pack area, that is this area. Okay, and this is the area where this part. So this part is the area where the hydraulic component sits. So initially I have taken a PRV, pressure relief valve, and connected back to the tank. What is the PRV? Function of a PRV here is, so you can set the PRV, pressure relief valve. For example, I'll give you one very good example. Suppose I keep on taking this session till up to evening, you cannot sit because your pressure valve will ask for a relief, correct? So in the same way, if the pressure exceeds in the system, the excess pressure has to be sent to the tank, here to the tank, because hydraulic oil cannot be wasted. We cannot leave that to drain. So we will be taking back to the tank itself. So means I set a here at 50 bar pressure. So it will, if it exceeds the 50 bar, so it will be going back to the tank. So that means my further pressure will be 50 only. That means I'll get some pressure here. So now I want to play with this actuator with different conditions and log few of the data. So what is the experiment here? I want to move this actuator to and fro using an electrical solenoid valve, and I rig up a wiring to it using, this is a solenoid valve. So I have not shown electrical circuit here. So there is a relay logical electrical circuit that can be built. So, and if I operate through that, I can move forward or move backward this. But while moving forward and backward, there are many cases like this. I want to move this now slow. So, or I want to put a more pressure on this side, so that there can be a differences in force that you want to put on a particular application. So like this, a different combination of requirements are being met on a machine. So I am comparing the machine requirement here onto an IoT laboratory now. So for the purpose of demonstration, last 2-3 days back only I have captured this. So I have connected few bulb sensors. Okay. So, and these bulb sensors, one of the data I have showed here. So after I switch on the hydraulic test rig, so this bulb sensors will give you a pressure. Says now the pressure is recorded here, and the pressure is this. This is between 40 plus pressure, and suddenly when I stopped it, it will drop. Okay, like that you can record the pressure. Also in the simultaneously you can know by currents and other parameters which are there in the here in the path. So connecting all that, ultimately we will be getting a graph like this or an Excel data like this, which continuously over a period of time anybody can monitor. For example, I will now link this case to an application of an industry. In one of the company called Copeland Corporation. So there they manufacture the hermetic cylinders for an R&AC applications, that is refrigeration and air conditioning application. So what is that they do is, they take a casted crank cases and hold it on a fine boring machine try to generate a fine boring surface, a mirror like surface within it. So suppose if you hold it with a more pressure, so the problem of cylindricity will not be met. So it has to be clamped at a particular pressure and maintained throughout the processes according to one particular definite requirement. If you do like that only, after you remove the crankcase and put a digital dial gauge and a software, your cylindricity parameters that you capture will meet the requirement, because very close tolerance is there. They supply compressors to companies like Hitachi, where the Hitachi clients put our AC in the night. You never find even a small, very small noises also. So which comes through the fan and other components of the AC. So the demonstration is like this. They drop a pin, the pin noise you can hear, but not the AC noise. So, but to do that, ultimately the process behind that is our R&AC compressor, our components which is integrated in the AC, within the AC, so which are all meeting a certain requirements. So such a critical parameters can be monitored and controlled. This we call it as process parameter monitoring through IoT. In the next slide, now to show some of the demonstrations of sensors, I have connected few sensors. This is a wonderful kit. The complete kit you can see now: digital port, input, output, and analog, voltage, current, and HIS ports in it here. Okay, with LED and power charging connections. So very simple kit as such. Okay, and it is a made in India product for the Indian institutions now. We are long way to go now, taking this device to different institutions across India. Definitely we will do that, I'll assure you that. And data logging of sensors lab through IoT. To demonstrate this, I have taken a position sensor. So position Bluetooth sensor has been considered. The sensor is here. You can see a cylinder like thing here, which is mounted on the table, on my table now. Yesterday only I have taken this data. So this is on my table, and the data logger is also on my table. I powered it up through my internet desktop internet. I have taken and given to this and connected the IoT kit to this, and I have rigged up a circuit and started pulling this in. So manually I did. Normally to demonstrate this, we can have a servo motor kind of thing, or a DC motor connected to a lead screw kind of arrangement, can definite movement in a linear scale. So we can correlate and compare the data of the Bluetooth sensor and the actual data. So actual and theoretical. Actual, normally lab should have this kind of comparison. So also you can teach a calibration kind of thing there. So you can generate that kind, but I have not done that because this is a recent sensor that I have procured. I'll be developing such a kit now slowly. So after connecting this, I have logged it. I've just manually pulled the rod and logged the reading here. So this is the graph that I have got yesterday over a small time duration in the afternoon. Okay, so from 4 o'clock to 4:30 or 4:10, like that I have logged it. Okay, so this is a web development part. In the web development part, an administrator can register and control the whole student, and students can register, and all our assets of the institution can be registered. So you will have a less headache in managing your assets, and you can have other devices in the college registered to this, and you can also log the student projects that you are carrying. Suppose tomorrow NBA is coming or NAC is coming, you need not worry. So you can link the complete student project through cloud to their NAC portals if you want tomorrow. So such a big advantage is there here. So all the data which you are carrying out in the laboratories can be linked at any point of time to anyone from the global or the local network areas. So this is the advantage. So now when I logged these data, so I have selected the analog ports because this is an analog experiment. Sensor which I have used is volute sensor, and the values that I get will appear like this. So, but as I said, this is not the distances. So, or maybe some values, but you can correlate and calibrate and make it convert it into a parameter. So you can select either millimeter, current, or any. So well defined here. So easily you can get any of those parameters. This is the experiment conducted at what time is shown here, 2020. That is in the month of October. So time also logged here. Okay, on 12th we have carried this data. Okay, so like this you get a complete. You can save the PDF. You can print that and you can download it. Means a complete kind of examinations can be conducted to students uh, even in the COVID situations like this. So this is an advantage for us. Now I challenge all my PG students need not come to college. They can conduct a complete lab from a remote location and they can do their exams remotely and we can evaluate on time without any time delay. Okay, so this is the advantage. But one of the important thing here is in the left corner, if you see a release data logger is there. What is this release data logger mean? If a data logger is hooked by a student, so and he has completed the experiment, but you have not released the data logger, then the same data logger will not take the other experiment. This is you can call it as a disadvantage, but I don't say this is the limitations of the instrument. So you can automatically release the data logger. So you can develop a software. So once he quits, so release of data logger can be done automatically. So we have not done that. We are yet to do that part. I'm forcing now HEDAC people to incorporate all these design changes. So slowly we will be bringing a complete solution to institutions without any hesitation to take forward these kinds of laboratories for the next generation teaching and learning process. So the next experiment was how we connect either a mechatronics kind of kit through a PLC and see that the complete thing is working automatically fine. So I have taken one of the mechatronics kit, a mini assembly line, which represents a manufacturing line. And this will be complete line is now broken into multiple modules. There are 4 modules I have shown here and n number you can create, and each module will have an independent PLC control. Or to a same PLC you can connect through a different cabling and different projects, and students will be given access to develop a logic. Means students will develop a logic to move the conveyor, to move this module 3. It is a pick and place robot. So these programs they will develop through a ladder or a structure text or a FBD function block diagrams. So using any of the standard languages which any standard IEC standard PLCs will use, and each now module is linked to an IoT through an RS232 thing. Okay, and we can also do this that looks like this. Now when we look at this, each now module is hooked through a data logger to an internet. And why I have showed this here, you can generate a same web like application here. It looks like a mimic of this conveyor and a sensor demonstration, and whatever is happening remotely, it can be seen through here. I think you might have seen a TV now, a small girl operating an agricultural this to make a noise in it to send the birds and other thing which is coming into the agriculture. That is a VI or something, regular TV advertisements that you see. So like that, students can generate a n number of things, and those can be linked as our sub-assemblies, and those assemblies can be linked to data logger and an internet. This is a wonderful methodology where students can be exposed to white and junior and those kinds of coding people also venturing a big version of these kinds of laboratories to take the knowledge to the students group. And the total later, after completing this PLC and mechatronic thing, we have converted the backup systems also. Backup is a EtherCAT model which has a single cable communication, that is input and output will go by a single cable. That is an advantage of this, and this can be hooked onto any sensor and even Myrio and other instruments. Basically, it is a wonderful architecture again done to a backup PC lab. So through which we are controlling servo drives, stepper motors, and other kinds of things. And lastly, as I said, we have considered a robotic lab wherein a KUKA robo is there. Here an interesting phenomena, we have integrated a data logger and we have asked the big people which are coming to the colleges to stand on a particular spot and program the KUKA in such a way that when I give a data logger instructions to this through the cloud, it can hand over a bouquet to particularly to that person, taking the video camera pictures to him. So what not we can do with this kind of situation. Normally, we are also working on playing arranging of a chess pawns on a chess board. So exactly, it will look into white and black, and it will put all elements of the chess components in its proper places without any hassle, taking the cloud instructions and with the help of a vision camera integrated to it. So means students can play wonders here. So by doing all these things, students will know about IoT, students will know about robotic programming, students will know about all controlling aspects related to IoT and larger controller like PC, PLC, and other things. So they will be stronger in embedded domain. They will be stronger in open source controller domain, like Arduino family, Raspberry family, like this. And they can bring in any devices and connect through this kit and make their own experiment. So we can challenge a center which is on IoT in the future that we are aiming, can give project to any number of students in the states. So just one or two supervisors, dedicated supervisors, I mean, here will be able to take more than 200 projects per year of engineering nature. So vision of creating such kind of project development centers are now being thought of through these processes. So this is a demonstration of KUKA giving a bouquet to a JD, Joint Director of KCTU, as they have funded us a big amount to develop a research center in the field of robotics. So it has taken the camera image and it has selected the same program and it has moved to that spot and it has given a bouquet to him. Like that, so we can do a wonderful experimentation even with medical segmented areas like pinning a backbone defects using a certain CT scans or any other images like that. So it is a very good area wherein robotics integrated into medical area, which is even in the COVID situation you have seen a robot is taking the temperature of a people. So and it is directly connected through a cloud to a doctor, and doctor is advising the patient. So like many parameters related to the human kind like BP, all these elements which we can monitor through some kind of devices We have now trying to develop a belt-like structure which is be put on a human body and which can give some signals to the doctor directly like that. So those are all cloud connected. So a lot of such things can be brought in here. So now let me take about how a project creation can happen. So this is the web development of the part of the software part of the system. So now Dr. Prakash, this is I have logged in here as an admin. Okay, and you can create a new project. Go to new project and create a new project. Enter the project name. Suppose project name is robotic programming through IoT through cloud. This whatever you want to say, you will be saying that, and select a lab. So ultimately, if I go here, it will be showing different labs here: robotic lab, IPC lab, PLC, hydraulic, like this. So when you say this, this is I have taken one test. So a test project which is created. Once you create that, you can create by student name, you can create by student USN number, on what date and everything, and submit it. That's it. That will be there forever till you delete it or till admin deletes it. Okay. So he can choose any of the laboratories and do the thing and develop a project like this. So it's very easy. Go to select, go to new project or this, and select the right labs and develop it. You can even select the existing project and you can generate a new project. Okay. So now, as you know, from the last 2-3 years or 4 years, we are working to develop such a very big center in the field of IoT and automation. So through the process, as you know, the students are very brainy. One of my student has thought of developing a smart cooking machine which can cook 8 to 9 South Indian dishes through a cloud command from a mother, okay, to his son. So this was demonstrated. So the student name is Madan G. Okay, and this has been patented. Now it is already published and in the final approval for the patent number. So a system and method for a cloud-based virtual cooking platform and an automatic cooking machine. So this is the title of the publication, patent publication. So even anybody can see this in the patent office publication site. Okay, so this has been done through ALTM Legal, which is our legal advisor for all patenting kind of related aspects. So institutional legal advisor is the one, and situated in Lovely Road, Bangalore. Okay, and the people here is our principal at that time was GL Shekhar. My name is there next, and other few professors who were involved in it, along with a company fellow called Anand Suvia that you can see. He is a Singapore fellow. He has sponsored that, and now the technology is being already into one level, even outside India also. So that kind of a IoT enabled product level exhibitions and patents were made using the technology knowledge that what we have gained over a period of time. Very interestingly, which has a carousel containers, which has a raw ingredients within it, and the raw ingredients can take a command from a cloud saying that I want to prepare a upma for 2 people. It will only deliver the all ingredients, including water and oil, of required amount, and sequencing is being done and synchronize the complete process. Upma has been made and distributed to people using this device. But one of the major problem that we are facing is washing of these kind of devices. We are working little on that, making this more utility oriented kind of thing. Definitely this will enter market. As you know, already there is a chapati making machine is hitting outside India now. Okay, similar kind of this machine will also now already pitched in Singapore and other countries now. Slowly, this will hit the market in the future, but it may take little time to overcome the existing problems and come to the market. Anyway, we have a published patent on this. And the second patent through IoT is already we are into IoT. However, we wanted to enhance our center to a bigger level. We have developed our own equipment called LabCon. So this LabCon can conduct an experiment on analog experiments like transistors, diodes, and other elements. So a live student can connect to this device through his mobile itself and operate this either using a hand gloves or using a goggle to see, and there is a button on the goggle itself. Two means are given to it. So give a command to the instrument and increase the voltage, increase the current, and capture the reading out of the device, and those readings are being taken into the system directly on an Excel tabular form and through a graphical form, and submit it through his mobile only in the next minute. So now you are seeing examination is being done online. So what the students are doing, so they are writing the exam sitting in front of a google.com, that is a website, and through which a teacher can see. Okay, and students completely writes it, PDF it, and submit it. Here nothing is required. Nothing is required. He hooks onto the machine. Live streaming will be done. He will be simply giving us some commands. As you know, students are very good with mobiles now, so they can give commands using mobiles. And as he gives the command, it will be transferred onto the machine, and machine will give its output data. And the output data is also visible to both teacher and students if required, and it will be taken forward to a PDF conversion and printing process, or sending to the teacher's process. So this is again a patent which Quran and Quran through we have done an individual patent done by a group of team, which is my team basically. So, and already we are into product level in this area also. So a method and system for performing experiments using a remote laboratory for an analog area. So this is the kit again. This is patented kit again, through which we can even do a sensors, analog sensors and digital sensors experiment, and transistors and other devices experiment, and how it looks we will just see. If you look at this now, the title which I have showed is Mobile Learning Based Remote Laboratory for Analog Electronic Experiment. So this is my paper in published in one of the Scopus indexed journals only, online journal. So you can see this journal completely if you want. So this is our inside this architecture, but I have not shown completely here because this is our IP part. Okay, and this is what you can see it in the mobile. So on the mobile you can see a complete screen like this, a voltage thing, and plus and minus. Just if you touch it here, pulse it here, it can generate a signals and come to our IoT device, IoT kit, and through which you can give, and which will be live video streamed on through a screen development part. And if a student wants to see through a 3D, even he can see through a 3D, like a 3D kind of a image, kind 3D image display kind of thing. Okay, so as you know, you can tabulate, you can ask for a graph, you can ask for a table, you can create a new table if you want, and do whatnot through your mobile only. So this is the beauty of this paper. So you can see this kind of new developments in the COVID situation. This is published in the COVID time. Okay, definitely will help the education segment in a big way in the future times. Okay, so now I'm also showing you the how the screen appears on a mobile. So this is mobile screens only. So you can your table values are shown here. Okay, and you can even export the table and other thing. And if you ask a graph, so this is displaying a graph here. Okay, which is a characteristic of a transistor or that. So you can even directly explain this to the student. So one of the important thing here is we have taken this into a studio also, so that while the lecture teaching the chapters, he can make use of this mobile app with a remote laboratory and bring the laboratory into classroom. So that means it can serve the purpose of a teacher, serve the purpose of a student, and serve the purpose of an examination, serve the purpose of NBA, or serve the purpose of data management or a project management kind of thing. So multiple advantages that one can have through these kinds of development. So I request everyone to go through with this paper, especially. I'll be, if you want, I'll give you this. So I would like to just thank everyone for seeing this presentation. Now I will take any questions from the participant side or any of the feedback. Prashant, are you hearing?
Thank you, sir. Yeah. So thank you for that excellent presentation. Now I would request participants, if you have any questions, you can directly speak and interact with the resource person. You can unmute and you can speak, or you can post your questions in the chat box so that we can take up the questions. So there are a couple of questions which the participants have posted. So they would like to know what is the difference between a normal regular hydraulic system and proportional hydraulic systems.
Yeah, very interestingly, suppose if you take a conventional electrohydraulic system, you have a solenoid valve operated, which is completely opens or completely closes upon giving a signal. So means through a relay, when the signal comes to the solenoid valve will pull the spool within the hydraulic valve completely. So that means you can take one position as a complete, but you cannot take in the middle. For example, I'll quote you one very good example. The fans which were earlier given like 1 2 3 4 5 6, that is a step control, I say. Okay, but you cannot regulate it from 0 to any value. So if you want to do that kind of regulation on flow or on pressure or on any of the parameters related to the hydraulic circuit design, then the people need to have a control valves which are proportional control valves, electronically operated control valves. There are two segments to it. Onboard controllers are there, which is mounted on the valve itself. A controller card is mounted, and other one is a rack type of a controller which is sits in the rack and through which you can connect and work through. So basically, in a simple way, if I want to tell, you can get a stepless control for a different applications. For example, deep drawing process. If you take a deep drawing process, so deep drawing drawing of into a cup. So when the press goes to the bottommost corner, so if you do it one shot and take it back, so there will be a phenomena called rupturing. So because at a on high speed, it has gone, pressed it, and suddenly if it gets retract, it will pull out the material. So normally what we do is a process called cushioning. So we go nearby, slowly press it, depressure it, and then take it, so that the deep drawn cup will be without fractures, without the process defects. So like that, there are many process rapid grip controls in many areas, like fine boring applications or any other processes wherein different industrial requirements will be there. So in such a cases, one need to have either position control, flow control, pressure control phenomena are required to be controlled stepslessly. Then the proportional valves will help us, and the proportional control circuits are built to do such kind of circuits basically. I hope I have cleared it.
Yes, sir. Yes, sir. Thank you. Sir, I have a question regarding this conversion of this conventional lab to Industry 4.0 lab. Now, you have shown us various hardware systems which can be integrated with the existing system. So my question, sir, is basically, if you have some traditional machine, let us say, which is not operated by any sensors, or no, which is not basically having any sensors or a control system as such. So, how do you connect, or how do you interface these traditional machines to IoT systems? Because there will be hardware incompatibility between traditional machines and these new kits, external kits. So, is there any standards?
Yeah. There is a standard to it. What we
Yeah.
call this as a flexible. So when we say flexible, so there are some of the components which are can be integrated to any such kits, which is more mechanical in nature, and you want to convert them into a kind which is eligible to be an IoT platform. So you need to buy those kinds of flexible devices and connect through that and make it as convertible sometimes. Like for example, you want to show a mechanism of 4-bar mechanism. So it is simply a mechanism, but I can convert that, drive that using some actuator and link a video streaming of that to explain it. Means it is possible, but we need to put in some more devices into it and make it lifted to one level before we get into an IoT. But sometimes a controllers like CNC controllers, which I have told, so which we have purchased, I think 6-7 years back. So the controller capability is not there. So now I want to change the controller itself. So the controller cost is around 1.5 lakhs. So it is not feasible. I don't go for such things. So if it is costly controller is there and I want to throw that controller, please don't do it. If it is no controller, you can put a controller. So that is a possibility. So because all the projects will like that only. You bring in any mechanism, you can drive through a relay circuit, or you can drive through a PLC circuit, or you can drive through an embedded controllers or a Raspberry kind of things. So whatever it is, the controller that you use. So you can use Arduino boards, you can use a Raspberry Pi. So the complete automated machine which works on Raspberry Pi now. So when you say that is purely mechanical and more of a DC motors which are involved in it. So we can convert such things and then take it into an IoT. It is a possibility. That is what we call it as, while development stage itself, you can bring in the flexible components and add in those components and make it more flexible to be convertible.
Okay. Thank you, sir. Is there any questions from participants end?
Hello, sir.
Yeah.
Sir, like if you have an idea on project and IoT, and if you have if you have a software model, like it would be very costly, no, sir, then to implement practically.
No.
If it doesn't work.
No. This is the wrong concept, actually. Please don't do that. Now, okay. Open source controller starts from 150 rupees. Arduino Uno, if you take, okay. You can get it for 150 rupees. So 150 is not too much. Once you go to a hotel, you will spend 1,000 rupees. Correct, na? So one-time food for 3 people will cost you around 800 rupees. But if you buy Adino, Una or Mega, it has a link to IoT. So you have to see that which controller, how many number of IOs that you can link, and what is your project. Is that is mapping is being done properly. Within 500 rupees, you can.
Sir, I have one more doubt, sir.
Yeah.
Sir, actually, I have taken a project on smart irrigation management, sir.
Sure. Tell me now.
Sir. But
you
in most
want
of
to tell?
Sir. I'll come. Sir, on smart irrigation project, I have a project idea, sir, and I had taken it already. And when I thought, like in South India, we almost cultivated crops just for 3 months, sir, almost. 3 months.
Agreed, ma.
When
3 to 4
we
months.
implement an IoT technology in a smart, sir, sir. When we implement it in a smart irrigation system, like it is highly cost efficient. Though it is very easy for a farmer, it would take more cost than what we get from crops.
No. I'll tell you one good thing.
Separate idea?
I have an idea.
Is there any idea to consider? Yes, sir.
Yeah, I'll tell about this. So we are bringing in a bot called Agri Bot only. So normally a agriculturalist want to know the moisture, temperatures, NPK values. NPK means phosphorus and other chemicals that is required for the
phosphorus, and potassium.
Nitrogen, potassium. So these are to be checked. So a robo which can travel inside an agricultural will be provided with this kind of sensors, and it logs the data and put it into cloud.
Okay, sir.
And if you put it into cloud, it will not go anywhere. So the data is there forever for you till you delete it.
Yes, sir.
So that kind of a data logging has to be done. Basically, SRV is a company which is a Pune-based company. They are trying to bring in a bot to an agri for these purposes only, to find the NPK and to know the moisture, temperature, and other parameters which are vital for the agricultural area.
Yes.
And tomorrow, if the technology grows up and mature, a few bots can work continuously 24/7 and cover a village.
Yes, sir.
Village in the sense the land belongs to those village.
Yes, sir.
So like that, if you try to do it on rental basis, you can sell out those kind of bots to capture the data. So definitely the future is towards that only. Very good question. And future is towards that, and people are working on that area.
Sir, actually I asked this question many times, like many people I know, sir. But they didn't explain, like there is a bot which can do all this. They just told like it is just costly process, and I thought like if we replace sensors every 3 months, it would be a burden to farmers. But thank you, sir. Thank you for your solution.
Good. Because I am working with these companies. That's why I am telling you the data. We are already into it now. Okay.
Yes, sir. Okay.
Thank you. Any other questions from the participants? Okay, so if there are no further questions, then I'd like to extend my warm gratitude and thanks to Dr. Prakash, sir. Thank you for that excellent presentation. I have explained the process of conversion of the conventional labs to Industry 4.0 lab, which is, I believe, is the need of the hour for every engineering institutions across the country, because industry is moving towards Industry 4.0, and whereas education institutions are still basically stuck with the conventional missionaries, conventional labs. So thank you very much. It was a very nice topic and was very insightful.
Thank you very much, and I thank NMIT for giving me an opportunity to present this area, because a lot more to go in this area. As a faculty, I am more keen on transferring these kinds of technology to the institutions so that the institutions are able to give a quality educations to the students group in the future. As you know, our Prime Minister Narendra Modi is focusing towards a revolution change in the skill development part as a whole. When we take engineering institutions, definitely we need to cope up with his visionary word and work for a future India. So all the future is our students, our kids. So even I have 2 kids. So like that, everybody will have a kid. So if we are able to give a quality education to them, we are able to convert our country to a next level. So I once again thank the institute and organizers for providing me an opportunity for this. And I thank HIDAC India, mainly Santosh. He's a close friend of mine, and we are working from more than 10 years together in different segments and product developments like this. So I thank him for his introducing me to NMIT for this purpose. So thank you, one and all. Thank you.
Yes,
And
absolutely. Santosh,
please send me
basically,
the recorded video part for me also for
sure, sir.
correcting myself.
Yeah, sure. I will be sharing the video. This is also being streamed, so we'll also share the YouTube streaming link, so you can just access it.
Thank you.
So I would also like to thank Santosh, because Santosh was basically a key resource person who was able to help us in getting connected with you, sir. And he is also part of this program. So tomorrow he is having one session, so he'll be delivering the session. So with that, I'd like to conclude this morning session. I would like to thank all the participants for patiently hearing the topic and interacting with the resource person. I would like to request the participants to kindly provide us your feedback for the session. The link has been posted in the chat box. You can access it and you can provide your feedback. So with that, I'd like to conclude this morning session. We'll again get back to you in the afternoon for the afternoon session. So thank you one and all for joining.
Thank you, everyone.